Hello, this is the yinsh game group presentation for Group 33. In this presentation, I and my team member will present the completion and the improvement of AStar and the reinforcement learning respectively, and compare them based on the BFS and choose the better method at the end. AStar is a heuristic algorithm to select action with minimum H value to obtain the continuous series. If the agent has to calculate H value every time the series is identified, then the time complexity will be high, so we pre-calculate the H value for all cases of series in a table. When the agent identifies a series, it can only needs to query the table to get the values. In the initial version of heuristic function, the state of series is divided into three cases. If the series contains the opponent's ring, then the H value is marked as 51, which is the maximum number of steps and means unreachable. If they are all empty in a series, then the value is 6. And if there are opponent counter in a series, we need to consider to use ring to convert counter and replace empty and count all steps of those actions. We made a test for initial version AStar, and the results show that AStar has no significantly more efficient than BRFS. Early actions were downgraded to the random action due to the time constraints. In the last few steps to form consecutive series, the original heuristic function does not yield accurate value and therefore leads to the efficiency of AStar. We changed the calculation for the case where the sequence contains opponent's counters. The ring will move in the direction with the most opponent counters by only one step, and the agent iteratively simulated the minimum number of steps to convert empty or opponent counter to the player counter, and finally return the value. The AStar demo is shown below.
When we talk about the reinforcement learning, the first thing we need to consider is the features. There are three pairs of features in this model. The first pair is talking about the score difference after the action applied by the self agent. And the second part is number of counters on the board, the difference of the counters, both for the self and the opposite. And the third pair is the inverse of the heuristic function generated by AStar. Why we use the inverse? Because in heuristic function like AStar, the larger value means far away from the goal, but in the RL model, the smaller value means is far away from the goal. And the way we normalize it is 1/1 plus h, because h is a non-negative value. And then we can somehow normalize all these three pairs features into a value between 1 and 0. And this will be very feasible for the prediction, not prediction, like, yeah, calculate the Q value somehow, yeah. And you will wonder why I will just choose 6 weights if you look at into my code in the weighted file. It's because the state and the actions are actually irrelevant. So if I choose for every actions, I give it a weighted value corresponding to the features. It just doesn't make any sense, because in a particular state, like the action is only meaningful at that state, right? So let me show you about the demo. This is competition between LR train model versus the AStar, and the green is the AStar, red is the RS train model, which means while playing we can like updating our weighted file, yeah, and so RL model wins. Thank you.